Welcome you all to this new video session. Today we'll be learning about Cohen Sutherland line clipping algorithm. Let us see how this works. Suppose we are given a line and this line is drawn in such a way that some portion of the line lies within the window and the rest of the portion of the line lies outside the window. So what we can do? We may encounter situations where we have lines which are completely outside the window. If the line is completely outside the window, then we can reject the line and avoid it from being displayed. What if the line is completely inside the window? If a line is completely inside the window, then we have to do nothing. It does not require any sort of clipping. We can save it inside the window and it will be displayed within the window. So we need clipping only if some portion of the line lies inside the window and the remaining portion of the line lies outside the window. Let us consider a line x1, y1, x2, y2. One point lies outside the window and the other point lies inside the window. What we can do? From the picture itself, it is clear that x1, y1 is outside the window and it requires clipping. After clipping, we need to find an intersection point and this intersection point will be in this boundary. Let the intersection point be labeled as x dash, y dash. So initially the point was x1, y1. Since it is outside the window, that portion which was outside the window needs to be clipped off. After clipping, you will get a new intersection point and the new intersection point will be labeled as x dash, y dash. So through this video we will be learning how we can compute x dash, y dash. Let us proceed to the next stage. Algorithm says first we need to find the region codes of the 2 points. So we were having 2 points x1, y1 and x2, y2, and using the region code rule we can find the region codes of both these points. And those who don't know how to compute the region code of the point, you may refer to my previous videos where it is clearly explained of how to compute the region code of a point. So using those calculations, we have computed the region code of both x1, y1 and x2, y2. From the picture itself, it is clear that x1, y1 lies outside the left boundary and x2, y2 is completely inside the window. Since x2, y2 is completely inside the window, the corresponding code of x2, y2 will be 0, 0, 0, 0, which means this point is neither above nor below. At the same time, this point is neither to the left of the window nor to the right of the window. So all the 4 bits will be 0. And what about x1, y1? x1, y1 point does not lie above the window, neither it is in the below of the window, but it lies to the left side of the window. So among the points A, B, R and L, out of these 4 bits, only the left bit will be set and all other bits will be set to 0. So once the region codes of both the points are computed, we have to perform an AND operation. What is an AND operation? AND operation, we are performing an operation in such a way that we will get a 1 only if both the inputs are 1. So if any of the input is 0, definitely the output will be 0. Let us AND the bits. 1 and 0. When ANDed will give you 0. 0 and 0. When ANDed will give you 0. Again 0 and 0 ANDed will give you 0. And finally 0 ANDed with 0 will give you 0. So we got 4 bits 0, 0, 0 and 0. After AND operation, we need to perform an bitwise OR operation. That means first bit will be ORed to second bit. The result is 0. There is 0 or 0 will give you 0. Again, the result will be ORed with the third bit. that is the result was 0. 0 or 0 will again give you 0. Again the result will be ORed with the last bit, and the final ORed result will be 0. So how can we perform an OR operation? OR operation says if any of the input is 1, definitely the output is 1. Okay, out of the total bits, if any input is 1, output will be 1. So here in our situation, all the inputs were zeros. So definitely 0 or 0 or 0 or 0 will give you what? 0 itself. Since the output is 0, it indicates that we have to accept the line and the line needs clipping. So the rule says after bitwise OR operation, if you are getting a 0, then you have to accept the line for clipping operation. What if you are getting a 1? After the bitwise OR operation, if you are getting a 1, then it clearly indicates that the line is completely outside the window and it needs to be rejected. After this stage, if the result is 1, we quit the algorithm by rejecting the line, and if the output is 0, we proceed to the algorithm for clipping operation. How can we clip? Again taking the region codes of both the points. We know that x1 y1 was having the region code as 0001 and x2 y2 was having the region code as 0000. From this it is clear that x2 y2 is completely inside the window and it does not require any sort of clipping, but x1 y1 is lying to the left of the window, and since it is outside the window it requires clipping. From this it is clear that the line which we have taken is in such a position that one of its point is outside the window and one point is within the window. So only the outside point needs to be clipped. How can we clip? Proceeding to the next section. The point to be clipped is x1, y1. Rule says in the region code, if the left bit is 1, in the region code, if the left bit is 1, it indicates that it requires, which means the point requires left clipping. If the right bit is 1, then point requires right clipping. If the above bit is 1, point requires above clipping, and if the below bit is 1, point requires below clipping. If the region code is in such a way that it is having 2 bit positions as 1 at the same time, that means suppose the region code is 1001, which means this point requires both above clipping and left clipping, since this point lies to the top left portion of the window. So we need to perform 2 sorts of clipping, one above clipping, and at the same time we have to perform left clipping also. So for each bit position we need to check whether the point lies outside the corresponding boundary. If it lies outside the boundary, then it definitely needs to be clipped. In our example, if the left bit is 1, then only left clipping is needed. Proceeding, how can we perform a left clipping? Rule says you can compute the new intersection point x dash y dash as x dash is equal to xw min. Xw min is the left boundary of the window. So setting the new x point as left boundary of the window, that means the value of xw min, and the new intersection point of y can be computed as y dash is equal to y1 plus m into x dash minus x1. What is this y1? Y1 is this value, that means our point. This point needs to be clipped, so this is y1. y1 plus m. M is the slope of the line. How can we compute the slope of the line? We know that If the line is x1, y1, x2, y2, then slope of the line can be computed as y2 minus y1 by x2 minus x1. So using this equation, you can find the value of the slope. So new intersection point y dash can be computed as y1 plus slope m into x dash minus x1. Now this x1 is taken from this value. What about this x dash? X dash is the value just computed. So if L bit is 1, the new intersection point can be computed as x dash is equal to xw min and y dash is equal to y1 plus m into x dash minus x1. Similarly, if instead of left bit, right bit is 1, then we can say x dash, that means intersection point x dash can be computed as x dash is equal to xw max, that means the value of right boundary of the window. And the intersection point y dash can be computed as y dash is equal to y1 plus m into x dash minus x1. Here x1, y1 are the point to be clipped. M is the slope of the line and x dash is the value just computed. Now if below bit is 1, we can say if below bit is 1, then y dash can be computed as yw min, which is the top boundary of the window. Setting the value of y dash is equal to yw min and setting the value of x dash as x1 plus y dash minus y1 by m. Here x1, y1 are the point to be clipped. Y dash is the value just computed and m is the slope of the line. And if above bit is 1, then we can say y dash is equal to yw max, which is the bottom boundary of the window, and x dash is equal to x1 plus y dash minus y1 by m. So we have 4 set of equations, one for each boundary. One for the left boundary, one for the right boundary, one for the above boundary and one for the below boundary. So depending upon which bit is equal to 1, we are applying corresponding set of equations. Okay, suppose the region code is 0010. From this it is clear that only the right bit is 1. So the point requires only right clipping. So we will be applying only the set of equations where r equal to 1. That means only this equation will be applied. So in this way, depending upon whichever bit is set to 1, corresponding set of equations will be applied to get a intersection point. Hope you got the concept of Cohen Sutherland line clipping algorithm, in which you can easily clip a line and find the intersection point. Hope the concepts explained over here are clear to you. Keep watching the videos and support me. Hit the bell icon to get all notifications whenever I put on a new video. Subscribe the channel if you are not yet subscribed. Thank you. Keep watching. Like and comment. Do give me the feedback. Thank you.